Don't forget to like, share, comment, and subscribe. Want to learn more? Explore our engineering courses on our website. Link in the description. Hello and welcome everyone. Very happy that we're all together again. In this tutorial, we will continue illustrating the manual loads calculations, but for another type of the interior loads, not an exterior one, which is the people thermal loads according to the SI system steps. So fasten your belt and let's get started. The aim of this tutorial is to know how to calculate the thermal load for the people who exist inside the building because of their bodies and the heat radiation from them. And we will do those calculations according to the SI system using the Asher tables and recommendations. So let's go ahead. First of all, let's see how to calculate the sensible load and the latent load for the persons. And here those are the two formulas for the sensible and the latent heat. So we calculate each of them in watt. After that, the first term of each of those two formulas is the sensible load per person in watt for the sensible load and the latent load per person in watt for the latent load. So let's see how to calculate the sensible and the latent load per person. Firstly, we must specify the type of the room that we are working on. So we will work now on a computer office room, which has an area of 9.1 meter times 5.8 meter. So its area is 52.7 meters square. After that, we will find we have this standard table for calculating the sensible and the latent thermal load according to the SI standard. And here the first vertical column represents the sensible heat per person in watt. So we enter this column as we need to detect the load in watt. And then the second column represents the latent heat per person and it's also in watt. And then the left column represents the space type, as each place will have a different value of person's sensible and latent heat according to the nature of the place. And now as our case is an office, so we will enter this row. And here we find that the intersection gives us a sensible heat of 75 watt per person. And it gives us a latent heat of 55 watt per person. So it's very clear that the sensible heat is larger than the latent heat, as we learned it from the previous sections, because the nature of the office doesn't need a physical work as the employees are sitting on the offices. So the sensible load now will be larger than the latent load. Very good. Now the second parameter we calculate is the number of persons in the place. And here we will find that we have this standard table that tells us about the estimated number of persons for the different types of loads. Here we are working on an office consists of some computers. So we suppose that this is a computer room. Then we have the estimated number of persons per each 1000 feet square. So the intersection between this row and this column gives us 20 persons per 1000 feet square. So we can multiply the office area that we calculated before by the number of persons per feet square, but don't forget to convert from meter square to feet square, as we have calculated the area before in meter square, so we multiply by 3.28. This is to convert from meter square to feet square. And finally, we will find this office to require 11 persons. Alright. Now we can get the latent load, but for the sensible load, there is a third factor that we must get, which is the CLF or the cooling load factor. So this factor supposes that the persons doesn't exist on the room all the 24 hours of the day, because the people in the office, for example, exists only for the working hours, which may be 10 hours. While the other 14 hours of the day will be empty. So this factor supposes that the persons don't exist on the room all of the 24 hours in the day, because the people on the office, for example, exist only at the working hours, which may be 8 hours, for example, while the other 16 hours the office will be empty. And the general case, we set the CLF value at which is 1. But if we need to detect the CLF correctly, we detect it according to two factors. The first one is the number of hours starting from the entry of the people to the space until the designing hour. So if we suppose that the people will enter the office from 8 a.m. and the designing hour is 4 p.m., at that case the first factor will be the number of hours from 8 till 4, which is 8 hours. So this factor depends on the duration between the people existence at the space until the peak load or the hour that we design the HVAC system on, and we detect its column from this row. Also, the second factor that we select the CLF according to is the total number of hours that the people can exist in the space at which, as we are talking about the total number of hours now which the people exist in the space at which. For example, the people enter the office at 8 a.m. and they leave the office at 6 p.m. So the total number of existence hours will be 10 hours, which are the hours from 8 till 6. And we select this value from this column. So for our example, we will select it to be 10 hours. Alright. Now the final factor we detect the cooling load factor according to is the zone type. And we have illustrated this zone type before in the solar thermal load calculations, if you remember, which was an exterior type of thermal loads. But here we are getting the interior people thermal load, not an exterior one. And we will use this zone type factor to detect its cooling load factor by the same way we have used to get the solar thermal load. As if you remember, the zone type depends on the nature of the building itself or the different parameters of the building, if it's a single-story building or it's a multi-story building. And if it's a multi-story building, we will select if it's the first floor of the multi-story building, or it's the middle floor of the multi-story building, or it's the top floor of the multi-story building. And in our case here, we will suppose it to be a middle floor of a multi-story building. Then the next factor we need to detect is the number of walls of the building that are facing a free space or they are facing the sun directly, and we will suppose them to be 3 walls. Then we need to detect if the ceiling is a suspended ceiling or it has no suspended ceiling, so it may be a concrete ceiling or it may be a concrete ceiling with a suspended false ceiling. Also, we need to detect the floor covering to be a carpet or a vinyl covering. Then we detect the partition to be a gypsum board or a concrete block. And finally, for the inside shade, we will select it to be a full inside shade of the window or a half or none inside shade. And for our example here, we can suppose this office to have a suspended ceiling, and for its floor covering, we can suppose it to be a vinyl covering. Then for the partition type, we can suppose it to be gypsum board. And finally, we have a full inside shade, hence we select this row. And for the column, we will enter now the people column, not the glass solar column, as we have handled in the glass thermal load. Hence, the intersection between this column and this row gives us a zone type D. Very good. Now we can get the CLF value easily after detecting its 3 required parameters. So we enter the CLF table with the zone type D and the total number of hours of 10 hours. Then for the number of hours for the entry to the designing hours, they are 8 hours. So the intersection between this column and this row gives us a CLF value of 0.88. Alright. Now we are ready to get the total value of the sensible and the latent loads of the people to be the Q sensible per person of 75 watt times 11 persons times a cooling load factor of 88, which gives us a total sensible load of the people of 726 watt. And for the latent load, it's the latent load per person of 55 watt times 11 persons, which gives us a total latent load of 605 watt. More than great. So that's about this tutorial at which we have learned how to calculate the people's thermal load according to the SI system steps. Hope that's clear right now. Thank you for watching and see you next tutorials. Don't forget to like, share, comment and subscribe. Want to learn more? Explore our engineering courses on our website. Link in the description.